Hello Year 8, welcome to our second lesson on energy, food and fuels. Miss Franklin has set independent work on SAM learning, which you should complete after you've finished watching this lesson. So the title is Food and Fuels. Please write that in your books. By the end of this lesson, you should be able to compare the energy content or the energy values of food and fuels and compare the energy in foods and fuels with the energy needed by yourselves for different activities. So let's crack on and see what's happening. Our lesson is also supported by the Activate 2 books, which you can access via Caboodle on pages 140 onwards. So 140, that starts the topic, and you can back up your learning by looking through the books. A quick quiz to see what you can remember from yesterday's lesson, or if you're doing this lesson on Wednesday, the lesson on Monday. So, question number 1. If energy is not used usefully, what do we say happens to it? Question 2. Name 3 energy stores. Question number 3. What is the law of conservation of energy? This will be quite a long sentence. Question number 4. What type of energy store is in an object lifted above the ground? If you have been in a G1 or G2 lesson, or a H1 and H2 lesson, could you please also write the equation for that type of energy store? Question number 5. What are the energy transfers for an electric light bulb? What goes into the light bulb, and what are the energy stores going out from the light bulb? If you need some more time to answer these questions, you can press pause. If you don't know the answers to the questions, you can use your notes from yesterday's lesson and you can look them up. So press pause now if you need more time. Okay, let's go through the answers then. If energy is not used usefully, we say that it has been dissipated. You could have had any 3 from gravitational potential energy, elastic potential energy, chemical, kinetic, thermal, sound or light, and of course nuclear energy, which I haven't put there. What is the law of conservation energy? Now this one is really important. If you didn't know it, I would like you to write it down because you need to learn it. Energy cannot be created or destroyed. It can only be transferred to other energy stores. And what type of energy is in an object lifted above the ground? It is gravitational potential energy. Don't get confused by gravity. You have to say gravitational potential energy. Gravity is a force. And the equation for gravitational potential energy is mass times gravitational field strength times height. Now the energy transfers for a light bulb, we have electric energy going in, we have light energy going out, and some energy dissipated as thermal energy or heat. Right, if you got 5 out of 5, congratulations, give yourself a big pat on the back, you're doing brilliantly, keep up the good work. 4 out of 5, really good, well done. 3 out of 5, good, but make sure you go back and look at the questions that you didn't get. Anything under 3, you really need to go back and look at the work we did in the first lesson and revise it. If you've got any questions, you can email myself or Miss Franklin. So how do we measure energy? Energy is measured in joules, and joules is a very small amount of energy. 1 joule is tiny. You'll notice that I've put joules with a capital letter, and that is because it's the name of an English physicist who in the 1840s was investigating energy transfers. And in light of his work, they named the unit for energy after him, so joules. So you need 10 joules of energy to lift a kilogram bag of sugar from the floor to the table, which doesn't seem like very much, but when you consider how many times you move in a day, you will start to appreciate how much energy you actually require. So because because a joule is a very small amount and we need large amounts of energy, we tend to measure or show our measurements in kilojoules. And 1 kilojoule is equal to 1,000 joules. Now, to put this in perspective with the food that you eat, and you're probably used to measuring in calories, 1,000 joules is equal to roughly 25 kilocalories, which isn't very much. So, moving on. So how much energy do you use? What I'd like you to do now is decide from the amounts of energy per hour below, which would use which activities would use what energy per hour. Pause your video now and do the work. Okay, let's go through the answers. So relaxing, playing football uses 3,600 kilojoules per hour. Oh, what's going to be next, guys? This is so exciting. I can't remember the order that I did it in. Woohoo! Oh, this is living the life, isn't it? Here we go. So 300 kilojoules per hour for sleeping. Remember, when you're asleep, you still breathe, you still move, and you still make noise. Yes, you probably snore, even if you don't know it. So what was going to be next? 600 kilojoules per hour for working. So you've got your brain doing lots of activity there, as well as your hand writing, your eyes looking at the page, taking in all that knowledge. And finally, probably one of your favourite activities is relaxing. It's 360 kilojoules per hour. So I'm guessing that you'll have all probably got that playing football was the highest energy user and sleeping would have been the lowest. So moving on again. So the government has made it law for all manufacturers of food to provide you with nutritional information, and that nutritional information includes the energy content of the food. So all packets must be labelled with the energy content, the amount of proteins, carbohydrates, fats and sugars, as well as salts, because all of these key nutrients will have a role in keeping you healthy. If the food is in the healthy range, be it the energy or the calorific content of the food is healthy, it would be highlighted in green, which says it's the healthy option. If it's sort of like not too bad, but you shouldn't eat it all the time, it will be amber. And if it's very high in fats or sugars or high in energy, it will be red. And this will be a warning. Don't eat too much of this, or eat smaller quantities, less often. So what I would like you to do now is, in a second, I would like you to go to your store cupboard and I would like you to look at the packets of food in there, and I would like you to find the packet that has got the highest energy value per 100 grams and the one that has the least energy by 100 grams. Now we do it by 100 grams so that the results are comparable. Remember, in science we always have to be able to compare things fairly. So if you give yourself 5 minutes to do that, pause the video, but do remember, when you have finished in that cupboard, make sure you put everything back tidily, otherwise I will be in trouble. Okay, pause the video, off you go. Okay, welcome back. I'm guessing that you found out that your crisps are very high in fat per 100 grams and that your baked beans have got lots of carbohydrates in them. And trying to think of a very low fat food that you might have in your store cupboard. Unfortunately, I don't have many in mine. Does that say about me and my diet? So what I'd like you to do now is there's a YouTube clip on how the government, or how we can find out the energy content of food. And this is how the government bases this information, and manufacturers of food can base this information. So it's a video of this experiment being done in a school. Now you can click on the YouTube link on EduLink. You can do it now, or you can come back to it later. So let's finish up with a bit of a knowledge check. So question number 1, I just want you to do a true or false. You can just write down true or false as we go. You don't need to write the question. Butter stores a lot of energy per 100 grams. Question number 2, celery stores a lot of energy per 100 grams. More energy is used to stand than is used to sit for the same amount of time. Let's stand up. If you use less energy than you take in from your food, you will gain weight. Think back to what I said earlier. To lose weight, you should eat more fruit and vegetables. Energy is measured in newtons, or energy is measured in joules or kilojoules. And lastly, you don't use energy when you are sleeping. You need to do a true or false for each of those. Pause the video if you need a little bit more time. Okay, let's go through it. I think you'll have probably got this one right. I hope so. Butter stores lots of energy. True. Celery stores lots of energy. False. You actually use more energy eating celery than you do than you gain. More energy is used to stand than to sit. That is true. Unfortunately, this one is also true. Big sigh. And to lose weight, you should eat more fruit and vegetables. This is a tricky one. Some of you may have got this wrong. So, yes, it's always a good idea to eat more fruit and vegetables, but you will only lose weight if you take in less energy than you expend. So, in other words, you have to reduce the amount of food and the energy that you're taking in, and you have to increase the amount of energy that you are using, and then you'll lose weight. Energy is measured in newtons. That is false. Energy is measured in joules. Yes, that is definitely true. And you do use energy when you are sleeping, so that was false, because remember, you breathe, you move, and you snore. Well done, guys. I'm hoping that you all did really well on that quiz. If you got less than 5, you need to have another look at this lesson. And if you've got any issues, you need to email either myself or Miss Franklin, and we will help you. So we have now compared the energy values of different foods and fuels. We've compared the different energy values, our energy needed for different activities. And we have looked at how data is presented with regards to energy contents for food packaging. What you need to do now is you need to go and do your SAM learning for this lesson. And we will see you tomorrow.